that all chemical processes are accompanied by energy changes? Well, in this video, we are going to talk about thermochemistry and its related concepts with energy, such as endothermic, exothermic, and enthalpy. Thermochemistry is actually a branch under thermodynamics, which focuses its study on relationships between chemical reactions and heat. It has an important field in the study, specifically to determine the particular reaction and whether it will absorb or release energy as it occurs.
All substance measures are joined by energy changes. At the point when a response continues, it either delivers energy to or assimilates energy from its environmental factors. In thermodynamics, these two kinds of responses are delegated exothermic and endothermic individually. A simple method to recall the distinction between these two response types is by their prefixes. Endo intends to attract and exo intends to emit. We will investigate these ideas in more details in the way of presenting the idea of enthalpy.
In thermodynamics, the enthalpy is the proportion of energy in thermodynamic framework. It is the thermodynamic amount identical to the all-out warmth of a substance of a framework. The enthalpy is characterized to be the total of inner energy in addition to the result of the weight and volume. In numerous thermodynamic investigations, the whole of the interior energy and the result of weight and volume shows up. In this way, it is advantageous to give the blend a name, enthalpy, and an unmistakable image.
Endothermic reaction happens when the heat is being absorbed by the system from the surrounding. It absorbs the heat, to which leads the surrounding colder. The one example of this is evaporation of water. So this is the example of evaporation of water. The water consumes the heat energy for boiling from the heater. It then transforms into a vapor of water.
Another example of endothermic reaction is an instant cold pack. If you ever sprained your ankle or fell from your bike, you probably reach for an instant cold pack. This is an endothermic reaction at play. Let's see how it works. In the bag, there are two components, water or H2O and ammonium nitrate. When the bag is broken up, water and ammonium nitrate mix. The endothermic reaction makes the water colder and the bag feel frozy and so good on your swollen ankle. Exothermic happens when heat is released by the system to the surrounding. It releases energy as the heat or a light.
Example of exothermic reaction is probably the easiest. Most readily available reaction is the one between laundry detergent and water. The next time you do laundry, put a bit of powder detergent in your hand and add water. Feel the heat? Be sure to rinse your hands thoroughly since detergent dries out skin. Another simple example of an exothermic reaction is combustion, such as lighting a candle. An initial input of energy causes oxygen and wax react to produce carbon dioxide, water, and heat.
As we all know, enthalpy is the sum of the interior energy and the product of the pressure and volume of a thermodynamic system.
So in this example, we're going to calculate how much heat is released by burning 125 grams of methanol, given its molar mass 32 grams per mole. In this chemical reaction, we have our delta H, which is negative 726.1 kilojoules per mole. So, if we have 125 grams of methanol, this is the same as having 3.91 moles of methanol, going all the way back to our grams to mole conversions. And then, we take this mole and multiply it by how many kilojoules per mole of heat this reaction puts off. So we put negative 726.1 kilojoules over how many moles of CH3 3OH from the given equation, and it is 1. So it is going to release negative 2,836.3 kilojoules. The reason why the answer is a negative number because the question says released, so the sign is negative, indicating it is an exothermic reaction.
Regardless the opposite result they give, both of these reactions obey the law of conservation of energy. The total amount of energy in both systems remains the same.
Therefore, all chemical changes require and use energy in every way. In chemical reaction, chemical bonds are either broken or formed. Its rule is when chemical bonds are formed, heat is released, and when the chemical bonds are broken, heat is absorbed.